Hello guys, today we're going to learn about the directional overcurrent protection. So let's start. Um, Say for example we have a power supply as indicated by this symbol and a load at the other side. So in a transmission line, typically we use this kind of protection to prevent from reverse flow um, from power uh, to ensure that our lines is still intact if one of the line is actually tripped or damaged. So as you can see here, we have protection relay at point A and B from one end to another end, and another parallel transmission line at point C and D. As you can see, we are using overcurrent, typical normal overcurrent protection 50 or 51 as indicated here, which is basically instantaneous overcurrent protection or time delay overcurrent protection. So this is a common protection. Before I introduce the directional overcurrent, let me just give you the idea of how it works. So as shown in this line, so as you can see, as the red arrow flows, this is actually how the power flow or the current flow from the source end to the load end, right? This is a normal operating condition. What happened when we have a fault at one of the lines, say parallel lines from point D to point C to point D, right? You can see that um, the current flow is no longer from the source to load, but instead from source to the fault point between point C and point D. Okay, as shown here. So we don't want this to happen. So what we actually respond to this is that we need to ensure that these two lines are even though experiencing fault current, okay, that is flowing through them, we want to make sure one of the line is still intact even though fault current passing through them. So this is clearly um, telling us that when the fault current is flowing, all of the relay at point A, B, C, and D are picking up the fault current. So what we worry here is that depending on the settings that we set on the overcurrent relay, all of the circuit breakers can operate at any point in time, which results in both two lines will be off. As a result, our load will not having continuous power supply. So this is where directional overcurrent come into play, whereby the green arrow as indicated here is the direction of current when it flows through it uh, to operate. Yes, to operate. So for example, if the flow of current, if the fault is at the bottom point just now, okay, bottom line, transmission line, the current from the top part will also move or flows down to the fault point. At the same time, current is flowing from this end towards the uh, fault point as well. So as you can see, 67 or the directional overcurrent will basically keep idle even though a fault current is flowing through them. But 50 or the typical normal overcurrent relay will always pick up when it sends the fault current depending on the setting, and will trip after certain delay or instantaneous setting set to it. Okay, but 67 is also the same overcurrent relay, but it will not trigger until the flow of current um, flows in the same direction as indicated as shown in the green color arrow, right? So like for example just now, flow current will flow from point A to point B, um, but then this relay at point B will not operate because it only pick up, but it will not operate because the direction is not as per the green line. But the moment when the current flows in this direction, in the green direction, that is where 67 will basically pick up and trip. As a result, it will separate this line, the fault line, from the fault current, and will keep this upper line continuously supplied by the power supply. Okay, so the current flow will continuously flow from generator or power supply through this line and then to the loads without affecting the continuity of power supply. So that's it about the directional overcurrent protection. So if you have any question, just comment in the section below and we can have a further discussion on the another type of protection or this directional overcurrent protection. Thank you.